Hello there, Jeremy from Rotronic. So today we're going to take a look at how we pull data out of RMS in a machine-to-machine kind of format. So this would be allowing data within RMS to be pulled into third-party software systems or even other pieces of hardware with software on board. So there's two ways of achieving this. We've built into RMS an API function. So that's an application interface that allows the data to be pulled out through that RESTFUL API, which is a very standard format. It comes out in JSON format, and you can use it that way. Or alternatively, because RMS is fundamentally built around an SQL database, all the data, all the configuration, all the settings are saved into a standard SQL database, then you can access the data through a standard means into the SQL. Now that is only possible if you're using an on-premise installation, because with the cloud we don't allow you access to the SQL data. But if you have on-premise or if you have an exclusive cloud, then you can use that direct SQL access. So first of all, I'm going to show you the API function. So this is standard RESTful API, as said, so it uses a JSON as the sort of format, and very similar to other APIs that you might have used out there. So what I'm going to do to demonstrate this is I've got a simple local system here running on a little mini server, RMS hub here, and I've got my local temperatures being logged and a rate of change. But what I'm going to do is use a little bit of free software called Postman. It's an API software, and it allows me to send the various commands I need to simulate requests. Obviously, if you were doing this properly, then you would wrap this all up into some sort of software, C++ or Python or whatever it is you want to use to run these commands and send the data to wherever you want it to go. So with this function we can use the cloud, because we are talking to the RMS software itself and requesting the data. So just like I'm requesting the data here via the web page to see a graph, the API function is allowing that similar sort of request to go through. So first of all, we have to request an API token. This is kind of a security key that gives us access to the data. And to do that, we send a request here. We have a standard post request, part of the RESTful API function, and we have headers. Various bits of information need to fill in there on the headers, all in the manuals, all in the online manuals, and there is also a blog on this as well. But the key thing is the body of the text. So here we have our function we're sending, and we are sending the information user ID to. So what on earth is user ID to, you may ask? Well, if we go into RMS and go to the setup here, then we go to users, and every user has a unique ID. Actually, I disabled this user, so let's enable that user. So user ID 2 is my guest account, so that's the account that I'm going to use in this case. On the cloud, the user number will be some 4-digit number, because we've obviously well past just 1 or 2 users, even though they're separate accounts. It's a sequential number. Anyway, so you need your user ID, you need your username, and you need your password. Let's go back here. So here we are. So we've got user ID 2, username is guest, password let me in 123, and the request type is data history, and we want the token to last for 30 days, which is the maximum we can request. Obviously you can request a new token all the time, but this will allow it to last for 30 days. So we hit send and we get the same answer we have down here. We get an OK response from the system, and we get this token, this string of text here. So that is my kind of password that allows me to use the API, and I get access to the data that this user has access to. So it does mean through this API function you can segregate access. So if the guest user only has, or this particular user only has access to certain parts of RMS, then they can only request data from that part, which is quite important for a lot of our customers. So now what do? Now we go to the data history part. So we've got a slightly different address we're going to here, data history request, and we are requesting the measuring point ID. Then we want to know data from a date to a date, how many readings to download, and the order. And the nice thing here is if you put a date really far in the future, like I have here, 2099, and you set descending, then you will get the latest results, because obviously it descends from 2099 back to now. So we'll put my key in there, And just to say, what is ID1? Where did I get that from? Well, if I go to measuring points again, the measuring point ID here is a sequential number as well. So I've made 4 measuring points. I've obviously deleted some, but I've got my temperature here, my rate of change. I think I had a temperature and humidity logger at one point, which I've deleted. So let's send that request, and I've asked for the single reading, and we get here again an OK response. I get the ID that I've requested, I get the name, which is helpful, confirms it's the right one, the parameter being measured, and I get the information. So I get that on the 16th of April at 23 minutes past 1, which is where we are now, and it tells me that it's UTC +1 as well, so it adapts the time for the local RMS time. I get my value 22.55. This logger is logging every 10 seconds, so yeah, there we go, slight change. If I wanted to have loads of readings, then obviously I just put in the count there, and that'll download the last hour of data there, 10-minute log interval, so you can see all the readings there slowly creeping up as the weather warms up. So that's it. So this is just using a test software to do this. It's very handy to prove the function works and to understand the structure of the response and so on. But obviously you could wrap this into Python, as said, or whatever, JavaScript, C#, C#, C++, whatever you want to use. But it allows easy access to the data. Okay, so that's the API. So the second option then is direct access to the SQL. And ultimately, this is no different to any other SQL database. So you could use any standard SQL interface to do that. But I will demonstrate this using Excel just as an example. So most important here is to have access to the SQL. It has to be your RMS installation. We don't give you access to the SQL via the cloud. So I do have a local installation, so I am going to go here in my Excel. I'm in the data tab, and I'm going to get data from database, SQL server database. I have enabled access to my server for SQL requests, which is pretty standard, but you may have to do it if you have RMS and the SQL on the same server, as I do. So yeah, so here's my server name, RMS Hub, and my database name is RMS. Again, that is pretty standard, but you may change it. So that's what we're going to do to connect, and then I will need to enter my username and password, assuming, yeah, there we are. So I'm going to enter my, now, very important to make you obviously have to have a user to access the database, and strongly advise using a read-only user account. I mean, there's no reason why you couldn't use a read-write user account, but you risk then editing the data and doing some serious damage to RMS. In addition, if you're in any kind of compliant or anywhere with a basic quality system, really, you shouldn't be editing that data. RMS will detect edits to the SQL as well directly, so it will raise up validation flags. So better to have a read-only user created by your admin team, so you can not do any damage. Anyway, we are username password. We're going to connect to the database direct, and away we go. This will be a little bit slow. Right, it's telling me there's not an encrypted connection. That's fine. I've not set up my SQL for encryption, so happy with that, but you could easily do that. So Excel will chew that over. It will be a little bit slow on my PC here, but we will get connected and we will see a list of all the tables any moment now. Here they come. So these are all the tables within the RMS database, and as I said, every piece of configuration within RMS is stored in the SQL. It means you can take that SQL away from the software, pop it somewhere else, reinstall the software, and everything comes back to life as it was. So what do we need? Well, data record is the key. These are the tables with all the measured values in. So here's the temperatures from my logger, the timestamp, the measuring point ID, and a sort of status flag there. So that's definitely one table I want to have access to, but I don't really necessarily know what measuring point ID1 is, especially if I have tens or hundreds of measuring points. So let's grab the measuring points table, which has information about the measuring points. We saw that we had 2 measuring points, and we can see the names here and all the other bits of information about them. And potentially we want the device as well, so we might want to know about the device. So there's a device table here which lists all the devices. So there are the 3 tables I'm going to load. This will take a moment. And once we are loaded, then we can start to analyze the data and create some relationships, so it makes it a little bit easier to use. Excel just chewing this over, it will get there. Because I'm logging every 10 seconds on this logger, it is actually quite a hefty amount of data in the data record 2. Data record 3 is all the data from, I believe, a day over a day old, so it kind of shifts, RMS shifts it into a second table. Right, it's all loading, it's getting there. Once this is loaded, then what I need to do is create relationships to tell Excel that these tables are linked, so that we can get, instead of having measuring point ID 1, we get the measuring point name. There we go. Okay, so the data's all loading. So, oh no, it's still going, come on. Alright, we're there. Good. So there are my 367,000 rows. That's why it took a little while. So let's do the relationships here. So is this yeah, okay, good. Usually get auto detect there, but anyway, so we're going to select here the data record 2 table, and we are going to link the measuring point ID to the measuring point table, and we're going to link it to the ID of the measuring point. So that creates the first link. Click OK on that, and then we'll do a second one that links the measuring point ID, device ID there, to the device ID. There we go. So that creates the links I need. You might be able to do auto detect, normally you can, I don't know if it works. Right, then we've done our relationships, so that makes the data a bit more usable, and we are not going to do that. We are going to insert a pivot table. We all love a good pivot table. And what do we want to do? I'll just do a basic demo here. So we're going to want to put values down in the values tab. We are going to want to put timestamp in the rows tab. That will take a moment. There we go, so there's all our kind of raw data in a bit of a mess, but we can filter by device name, so that means I can select for different devices. And actually I don't really have very exciting data here, but I would put the name in the columns. If we had temperature and humidity, we would have the temperature and humidity values there. So let's see what that does for my pivot table. There we are. So okay, so I can filter here for, instead of all devices, I'll just select my PT100 logger. Don't need the grand total tab, but we'll leave it for now. And obviously I can sort my time, my newest to oldest. This will take Excel a moment. My lowly computer struggling, thinking about it. There we go. Okay, so 1229. So we can see here it's 1331. So this is coming raw from the SQL, and all the SQL data is stored in UTC time, so coordinated time, very standard for software, so you would need to adapt this to your local time. We saw in the API that the data is adapted for local time. So here we are though, I have my data, and I can now go and do whatever I want to do with it, and I could have access to all the other devices if I had any. The only one I can choose is something with no device. Hello. And that would be my rate of change. It'll probably take a moment to load. So there we are. You could use Access, you could use any other piece of software to obviously do this. You just need that user account, and you need that access to the SQL itself. There's my rate of change, we can see, so slightly warming up here slowly. There we go. So hopefully that's useful. That's 2 examples of how you can access data within RMS in a machine-to-machine way. I've obviously done this all manually, but you could write everything I've done into software, and it might allow you to pull a temperature value out onto a label printer as you print your packaging labels. It might allow you to integrate data into more advanced kind of BMS type systems, or particular reporting platforms that you have, whatever you need. So RMS acts as the central store. It acts as the main device management. It gathers all the data. It's secure, and it's compliant to the pharmaceutical standards. But we know that people want to be able to take data further and do more with it. So that's why we allow these two approaches. The API also allows data to flow in, but we'll do that another time. So please comment, any questions, reach out to us, and yeah, we will see you next time. Thank you.